Hi Prof, we are Group 10 and today we'll be presenting on the group project. So to set some context, we are consultants the firm hired to recommend business findings to management. Here's a table of contents. I'll share about the topic of our project, the modeling approaches we took, results obtained, and lastly link it back to some business findings and suggestions for the firm. So the topic we decided to work on is to forecast the cancellations of hotel reservations. This is to help managers operate more efficiently. With the rise of third-party apps and other options such as Airbnb, we found that there's a rising trend of cancellations in the industry. These cancellations are disruptive and can greatly affect the operation of hotels. Hence, our goal is to minimize booking cancellations by looking into the customer segments of the hotel and predict the likelihood of cancellations in order for the hotel to better manage the customer flow. So we chose a dataset from Kaggle. This dataset contains information such as when the booking was made, the length of stay, number of children, and more. There are a total of almost 120,000 rows, and our chosen target variable is the is cancelled column. This column is a categorical variable and is binary, indicating if the customer cancelled the booking or not. After data cleaning and analysis, we used these 25 independent variables for our main analysis. In order to better understand the data set, we did some data exploration. We found that there are two types of hotels, the city hotel and resort hotel, with majority of the bookings being in the city. And as expected, there are also more cancellations in the city hotels. We also did a preliminary analysis on the average daily rate, or ADR for short, and room type as part of our initial hypothesis, as we believe these two variables might be a potential factor leading to the cancellation rates. So the data is stretched across 2 years, and we found that the peak period for the hotel is during about the middle of the year, with bookings and hotel rates peaking in August. So we used the 3-step approach to come up with our model. Firstly, clustering. We believe that customers can be clustered into different groups and that have their own unique properties. Hence, by identifying these clusters, we can generate deeper insights and offer better solutions to the hotel. Secondly, we will use supervised learning to test different models, mainly CART, random forest, and logistic regression, to find out which model is able to best predict the cancellation rate. Do note that it is imperative that we balance out the penalty for false positive cases and the benefit of overbooking, as they could affect customer satisfaction should the algorithm be too robust and overbook guests. Lastly, to evaluate the performance of the models, we will be using the ROC curve and confusion matrix to choose the final model for each cluster. So we standardized the data prior to our k-means clustering. Initially, we faced some issues with k-means as it was not powerful enough to account for the categorical variables. So we eventually relied on k-prototype clustering, as it was able to capture both the numerical and categorical variables. And through the silhouette plot on the top left, we found 6 optimal clusters, and I will elaborate more about them in the next few slides. So this table shows the value of the centroids derived from the k-prototype clustering. These clusters are based on our training set. The first cluster is the hotel's spring customers. It is the second largest cluster and forms the general bulk of customers that made reservations in May. They are mostly first-timers and adults. The second cluster we identified are the early birds. We found that this group of customers book way in advance, with some people booking even 300 days earlier. And also, these people also have a higher history of cancelling bookings. The next group is what we identified as the business travelers. This group of people book through corporate channels, have shorter lead times, and are mostly frequent customers. Next are the what we call autumn customers. They are the biggest cluster during the peak period of the hotel. This group of people are mostly first-timers, and interestingly enough, they have a relatively high number of special requests. Next are the family cluster. This group of customers have more kids and are also the smallest group of the hotel's clientele. And lastly, we have the leisure and affluent cluster. This group of people are willing to pay a higher daily rate and usually also have special requests. So the hotel should take note of this group of people if they are looking towards more affluent customers. So after the custom segments, we predicted on the test set, and these are the breakdown of each cluster that we will use in our test sets.
I will now talk about the findings that we got from our three models: logistic regression, random forest, and CART. So firstly, for the first cluster, which consists of mostly adults who are first-timers arriving in spring, it's the biggest cluster derived from our dataset with 22.5K data points. After predicting our models on the train and test set, we decided that the most suitable model for this cluster is random forest. The reason why we chose this model is because the variance across the five-fold cross validation is low as compared to the other two. And the trees have been tuned to prevent overfitting by using the expand grid function with m try equals to 15 and minimum node equals to 5. If tree in the random forest is deep and variables are randomly chosen in building the model, hence the higher training AUC achieved, since more features could have been selected and explained when building the model. Hence, although the difference in AUC between the train and test set is relatively huge, it might not necessarily indicate that the random forest model is overfitted. Based on the importance table as shown on the left, the top three most important variables are lead time, non-refundable deficits, and the average daily rate. According to the confusion matrix as seen on the slide, where no equals did not cancel and yes equals to cancel, the accuracy rate is 0.8464, predicting 30.1% cancellation rate, although the actual rate is 35%. Sensitivity rate is achieved at 0.919, so there is actually a low false number of false negatives, which is good as we do not want the model to be too aggressive. Next, for cluster 2, which has 8.9K data points and consists of early birds, we decided to choose CART. All the models achieve very high trade set and test AUC of more than 0.9 after tuning. For CART, we tune it using tune length equals to 10 and minimum bucket equals to 100. Since all the simple and complex models achieved high and train and test AUC, it could mean that the independent variables are highly predictive of the target variable. Moreover, the five-fold cross-validation result shown in the box plot shows small variation across the folds. Any model can be used here, but in this case, we will select a more simple and more interpretable model, which is CART. By looking at the confusion matrix, we can deduce that the predicted cancellation rate is 74.4% and the actual rate is actually 73.3%. With that said, we achieved a higher accuracy and sensitivity rate at 0.961 and 0.955 respectively, highlighting there's also a low number of false negatives, making it a safe and conservative model. And based on the tree that was plotted from the CART model, we can also infer that customers who are more likely to cancel are customers who are able to get a refund for their deposit paid when booking, representing 66% of the cluster, and customers who are most unlikely to cancel are those who are unable to get a refund with many special requests made and have cancelled less than once. Also, the top three most significant variables are deposit type, customer type, and total number of special requests. For cluster 3, it's the smallest cluster with only slightly over 2K data points. It represents business travelers who are regulars and prefer short lead times. Similar to cluster 2, the AUC is high for over 0.9 for all of the three models on the test and train set. However, the random forest model may be overfitting due to the huge difference in train and test AUC. Also, given that it's a small cluster with limited data points, the likelihood of overfitting is higher. Therefore, further supporting our stand that it might be actually overfitting. Hence, in this case, either logistic regression or CART is suitable, but since the variance is actually smaller for CART, we will choose CART. The predicted rate is actually 16.3% and the actual rate is 14.4%. We have also achieved sensitivity rate of 0.977, highlighting that the model is also safe and conservative, similar to cluster 2. Customers who are most likely to cancel are those who have made at least more than 2 bookings before, but have made at least 1 cancellation and stopped from the corporate market. And customers who are unlikely to cancel are those that never canceled before and arrived from 2016 onwards. The top 3 most important variables that affect the cancellation for this cluster are previous number of bookings not cancelled, arrival year, and lead time. Next, for cluster 4, it consists of customers who come in mainly fall and it's a peak period for the hotel. The total number of data points in this cluster is 21K, making it the second largest cluster. And comparing the curves and cross-validation results in the box plot, we have chosen the random forest model and the tuning parameters I shown above. Although the test AUC achieved was 0.993, we actually do not think that it was overfitting, as there's low variance in out-of-bag error as shown in the box plot, and the trees have been tuned to select m try equals to 14 and minimum node equals to 5. Hence, the higher training AUC was achieved since more features could have been selected and explained when building the model. Hence, the difference in train and test AUC might not necessarily indicate that the random forest model is overfitted. Next, looking at the confusion matrix, we also achieved an accuracy of 0.861 and a high sensitivity rate of 0.953. The predicted cancellation rate is 22.9%, the actual rate is actually 30.3%. And based on the importance table on the left, the important features are lead time, deficit type, and also ADR. These are the variables which have a higher significance in predicting whether a customer cancels or not. And likely the case at the peak season for hotel would mean that people would like to book in advance.
Next, we'll be moving on to cluster 5. Cluster 5 consists of families who come with their children and babies, and they tend to have more special requests, and they also stay for a relatively longer time. So comparing the ROC curves as we've shown here, logistics regression, CUT, and random forest, we've chosen the logistic model. The logistic model has achieved a lower AUC as compared to random forest. We find that the logistics model is more interpretable and less computationally heavy than random forest. The AUC achieved is also not far from the value that random forest achieved, and we also believe that random forest could be overfitting due to the difference in the train and test AUC. Moreover, as we can see from the box plot at the bottom left corner, the in-sample cross-validation results show in the box plot that the logistics regression achieved a smaller variation in results as compared to both the CUT and random forest model. So this could mean that there are linear relationships that are better explained through the logistics model. Based on the logistic model, this is the results that we've achieved. We've achieved an AUC of 0.804 when predicting on the test set. The confusion matrix has been generated based on a default threshold of 0.5 for P, and we achieved an accuracy of 0.738, which means that we correctly classified 74% of customers. While this is lower than what some of our previous clusters achieved, we believe that it could be that the independent variables here are not as predictive as the other clusters, hence the lower accuracy achieved. However, it still achieved quite a high sensitivity score of 0.808. The significant variables are as shown here. Do note that this list is not comprehensive. Next, to interpret some of the results we've gotten in the logistic regression, we've chosen some of the variables to interpret, as there are quite a lot of significant variables here. One, lead time. The increase in 1 day is associated with 0.5% increase in the likelihood of cancellation. We believe that this factor could be quite significant because this cluster has a centroid of 89 days, which means that the lead time could be a huge factor. Next, for booking changes, more changes could mean that there is a decrease in likelihood of cancellation. This could mean that they are more committed to the stay, hence they are making their booking changes instead of cancelling. And lastly, they are making more special requests, and this is associated with a decrease in the likelihood of cancellation. Since this is a family cluster, we believe that they could be making more special requests in order to accommodate to their kids. Next, for cluster 6, this is the leisure and affluent customers. So their habits include like longer stays, higher average daily rate, and more special requests from them. So from these three models, we believe the random forest might be overfitting due to the large difference between train and test AUC as compared to the logistic model and the CUT model. Between the two simple models, the CUT and the logistic model, we have chosen the logistic model because, as you can see from the in-sample variation based on the 5-fold cross-validation, logistic achieved a much smaller variation as compared to the CUT model. This is what we achieved when we ran our model. We got an AUC of 0.799 when predicting on the train test set. This is also the confusion matrix that we generated based on the threshold of P equals to 0.5, and we achieved accuracy of 0.778 and a relatively higher sensitivity of 0.897. So the significant variables are shown, and our model predicted that there will be 24.2% of cancellation in this cluster, and the actual cancellation rate is actually 32.5%. This is our interpretation of the coefficients as shown. So some of the significant variables that we have picked out is that resort hotels associated with a less likelihood to cancel than those staying in the city hotel, most likely because this is our leisure and affluent customers. and they are willing to pay a higher price. Previous cancellation, increase in one previous cancellation is associated with a much higher likelihood of cancellation. Adults, so increase in one adult associated with 22.7% decrease in likelihood of cancellation. This would mean that these leisure and affluent customers are coming in bigger groups and mostly adults. Total special requests, increase in one unit is associated with 47% decrease in likelihood of cancellation. To summarize our 6 models, we have made 6 clusters: Spring, Early Birds, Business, Autumn, Family, Leisure, and Affluent. So they all have very different characteristics to them, and we ran different models that we think that will fit the segment the best in our analysis. We've identified some of the significant variables. Of course, there are many more variables, but we've chosen some to show here to summarize our findings. Of course, based on the customer segments, we've come up with some top factors for cancellation and some business insights and recommendations we would like to give for the business. So firstly, for the spring customers, this is one of the main customer groups because this is one of the peak periods. So cancellation will be very crucial and will affect revenue quite badly. We would like to suggest that the hotel can include such that there will be a penalty fee for last minute cancellations and that the deposit cannot be refunded, etc. Second, early birds. So these are the people who book very, very early, and they have the highest likelihood of cancellation at 70% cancellation for this cluster. So there should be a higher penalty if you book in too early in advance and you cancel too late. So to reduce the amount of cancellations from this cluster, and also using the insights from here, the business can also better predict if these people are likely to cancel and open up their slots early in order to increase their revenue and book more customers. So thirdly, for the business travelers group, so these people are associated with customers who they have a history of cancellations, but they're also a lot of repeat customers. So what will work would be to establish corporate ties with the firms so that they are better able to communicate their schedules and book ahead, since this is a regular customer base. Next, for autumn customers, this is also another main customer group because this is one of the peak periods. So what could work is to send reminder emails so that there is less likelihood of cancellation, checking in with the customers whether they are still interested in continuing their reservations, and of course, incurring a small penalty fee for last minute cancellations. For the family cluster, hotels should be more prompt in helping them with their booking changes and needs. After all, they're traveling with their children and kids, so they are likely to have more demands and needs. So if the hotel is able to meet such needs, that would be more beneficial for the hotel. Lastly, for the leisure and affluent group, these people have one of the longest stays and they are also paying a relatively high average daily rate. So this is the more premium customer group, which the business should focus on, and they should think of offering more premium services and cater to their specific needs and find out more about what they would desire for in a hotel, so to reduce cancellation and profit more from this segment. With that, we've come to the end of our presentation. Thank you so much.